So the first problem is minimum operations to make array sum divisible by k. So you're given an integer array nums and integer k. You can perform the following operation in number of time. Select the index and replace nums I with nums I minus 1. So basically we'll have to select the index and decrease the value by 1. Return the minimum number of operations required to make the sum of the array divisible by k. Okay. So mhm, mhm. So we need to make the sum divisible by k, right? So there is a current sum, current total sum obviously, and so we can just make the numbers negative, right? Yeah, so I think this is fairly simple. Like 9 plus 3, 12. The first test is 9 plus 3, 12, 12 plus 7, 19. And we have 5. So we just have to figure out which is the multiple of 5 just before 19, which is 15. So we just need to subtract 4. So that the answer is 4. So yeah, that is quite simple. 4, 3, 7, 7, 8. Don't have to do anything 3 to 5. But the k is 6. So the we have to subtract 5, so we'll get 0, and 0 is divisible by 6. So the answer will be actually pretty simple. We'll have the sum. I hope the sum does not overflow. It still stays in the range of integers. So in sum equals 0, or in val in nums sum plus equals well. So this is the current sum. What I have to do basically, for example, like if we have the first instance, right? 397, 397, which sum was 1690. What I will do is basically divide the sum by k, which will give me like 3, right? The floor value 3 into 515. And we'll just result equals to sum minus this into k. This should work. Just one thing is you need to check, does it work for this test case? If this sum is 5, the sum by 6 0 divided is 0. So 5 minus 0 into something equals to 5, it will be 5. Yeah. So we don't. And that is a solution. It should work fine. We'll just start the code. We'll just submit. I think it's a simple one. It's very simple. Yeah, so accept it. Like you should not have taken this much time. You should be faster. Okay. This is the first contest actually in Leetcode, so I'm a bit confused. Like, where am I? Okay, where is the problem? Okay, so let's solve the second one, which is an bitwise problem. Now I'm not very good at bitwise. Let's see what happens. The problem says number of unique XOR triplets I. Okay. Unique XOR triplets. So you're given an integer array nums of length n, where nums is a permutation of the number in the range 1 to n. So I have an array. The array contains the permutation of 1 to n. An XOR triplet is defined as the XOR of 3 elements, nums I, nums j, and nums k. So XOR triplet means XOR of 3 elements from the nums array, where I less than equals to j, j less than equals to k. So like in order. Although it does not matter when XOR is there in order or not. Return the number of unique XOR triplet value from all possible triplets. Okay, so what's the constraint that we have to check first? The constraint is 10 to the power 5, so we can't do brute force. But the brute force idea is like 3 nested loop, but we can't do that. So mm, let's try to understand the problem a bit better. An XOR triplet is defined by the XOR field, and I have to return the number of unique XOR triplet from all possible values. IJ can be equal. It's also in case. Let's take a good example. So let's take 3 to this one. So suppose we have this 3, 1, 2. Okay. So if I do the XOR 3, XOR 3, XOR 3, I think it gives us 3 because when you XOR same number, it's 0. When you XOR something with 0, it's that number. So it's going to be probably 3, right? Okay. So same goes for 1, right? 1 XOR 1 XOR 1 equals to 1. So let's just verify because I'm not 100% sure. This is 3 in binary. 3, 3. Yeah. 1 XOR 1, 0, 0 XOR 1, 1. I hope you all guys know how the XOR works. Anyway, 1 XOR 1, 0, 0 XOR 1, 1. Yeah. So this is a very interesting insight that when we XOR the number 3 times, we get the same number. What it means, we're always going to get all the unique numbers, right? If my array is something like this, 1, 2, 3. So I know there is at least 4 unique XOR, well, at least, which is basically this 4. And now there can be always multiple. Now you have to understand how this multiple comes, right? Okay, so let's try to think. So let's say we have 5, we have 7, we have 8. Let's take this example. So let's try to think what can be the unique XOR values. So obviously 5, 7, 8, they're going to be there for sure. Now, what I can do is like 5 XOR 5, which is 0. And if you XOR 0 with any number, that's exact number. Okay, so that does not work. Okay, it's not going to work. What it can do. So, so like 5 XOR 7. What is going to give us? 5 is like 1, 0, 1. 7 is like 1. When you XOR, it becomes 0, it becomes 1. And we get 2. Interesting. But we need to do another XOR, right? With 8. 8 is 3 points. 6, 0, 1. 0. Which is 1, 2, 3, 1, 2, 4, 8, 8 to 10. This is 10. Okay, but we are not getting anywhere. What are the insights? Let's try to read the problem again. Maybe we understand something. An XOR triplet is defined as the XOR field value. I have to return the number of unique XOR triplet value possible. So if I want to think what can be the maximum XOR value and what can be the minimum XOR value, what about that? Mhm. Are we going to get every value between the max and min? No. But see, here minimum is 0, maximum is 3. We got all the values between minimum and maximum. This is a greedy hypothesis. Probably, if we can find the minimum and the maximum, every value in between can be achieved in somehow. So let's try to figure out what might be the minimum and the maximum XOR values. Let's take our case, right? This one with 5, 7. What can be the minimum XOR value here? I already did XOR of 3 values, which was 10, definitely not the minimum. So usually one idea can be probably the minimum is XOR the minimum number itself, because if we execute 3 times that number, it gives us a unique XOR value. So this is one idea. The minimum number of the array probably can be the minimum XOR values, which does not seem a very strong idea, to be honest. Because, for example, if we had okay, if we have this, right, 5, 7. Let's see what hard value again. 5 is like 1, 0, 1, 7 is like 1, 1, 1. If we XOR, we get 0, 1, 0. But what if our next value is something like this? 0, 1, 0. The exact same value of the XOR. What will happen? XOR will be 0. And it's minimum. Or maybe the XOR value of 5 and 7 is 0 and 0. Maybe our third value is something like this: 0, 1, 1. Then our XOR value is going to be 1. So, yeah, we're not going anywhere. So let's take the hypothesis we made earlier, like we're going to get every single XOR value between minimum and maximum. So, which does not seem to hold true in case of 5, 7, 8, because can you get 6? We can't. Like in case of triplet, they can only 4 value, which is 5, 7, 8, XOR of all 3, which is 10, and there is nothing else. You know, there is nothing else, because in all the other cases you have to XOR one value 2 times, that will become 0, and then XOR with third one, eventually will become the value that third one contains. So basically does nothing. But at least for 3 value we're going to get 4 XOR value. So because there is like interesting pattern, as we have to follow I like less than equals to j, less than equals to k, something like that in order. We have to follow this binary format, you know, I thought of that. I'm so confused. I don't know what I wrote, why I wrote. Uh, what I tried to say there. We have to maintain this point. I listen here, listen here. Isn't that hard because we're only concerned about triplets. Yeah. So like for example, we have like 50 values. How many triplets there are going to be? We fix one for each 50 value, we can fix like 49 second value. 40. Yeah, that's a lot. That's so no no. We're having how many people? Thousand, already 1,000 people solved, but like submission was 7,000, acceptance is pretty low. So I don't know. Should we move to third question because I'm not very good. Oh, I don't know. This lost. Okay. So third question is, again, it's so oh my god. I'm so confused. So, so if we want to have some decent rating, we just have to solve this. Okay, so let's start from beginning. Let's try to read the problem again because the more you read the problem, the more new ideas comes into your brain. So who knows? We're given an integer array of nums of length n, where nums is a permutation of uh, okay. Wait. There was like very important thing. Oh my God, I just forgot. Nums is a permutation of 1 to n. How can I forget this? Oh my God. Okay, so let's try again. I just, oh my God, how can I forget this, man? So nums is going to be like 1, 2, 3, 4, or like 4, 2, 3, 1, or like whatever. Now, I want to ask you, in case of XOR triplet, does it matter in which order we do the XOR? It does not. So basically, none is the permutation. We can basically assume it's always like that. This or this. It's always like this. We can just assume that because we- what we're going to do is find the unique XOR, right? And like yeah, damn. So okay, now this is very interesting. You know, now this now at least I feel like probably I can solve this. First of all, we have already four values as discussed earlier. 1, 2, 3, 4. They're then first answer. And then what can be other answer? Like the thing is when you XOR okay, what can be other? So I want to exhaust three values, right? Three values at time. And like always, if I have one, so on, I will have one or something. So what I'm trying to say, that what might be the three values? Mhm. Hmm, yeah. Like what I would want to say, one, two, XOR them. 1 0 1 1 0 1 1 0 0 0 0. We have 0, which is another unique value. So, very good. You know what it means? It means like for any permutation greater than or equals to 3, we will have this, right? So now we're going to have this. Interesting. What about 2 3 4? 1 0 1 1 0 1 1 0 0 0 1 0 1 1 0 1. Yeah, compared to 1 0 1. Huh? Okay. I'm back, but I don't know how to solve this. Uh, okay. What I was saying, one, so okay, so we get number 415, interesting, which is interesting, obviously. Now, what about 1 to 4? 1 0 1 1 number 1 1 1 1. Oh, which is 7. Very interesting. We get 7. Can I get 6? 6 is like this, right? Um, good. Can I get this? I don't know, like, what about 1 3 4? 1 0 0 0 1 0 1 1 0 1. Yeah, this is like 6. So you got 5, you got 6, you got 7. Interesting. Very interesting. Is there any number? So apparently it seems like we're getting 5, 6, 7, 8. So when I take 1 to 4, I think all the numbers from 0 to 7. And I don't think we can get more than 7 because, yeah, we don't have 4-digit in binary number. That is the answer. Like 0 to 7, every single up with 8 number. This is the answer. Yeah. Okay. Okay. So let's take 1, 2, 3, 4, 5. But we already know using 1 to 4, we can get 0 to 7, no doubt. Now I want to see how far we can go, right? How far we can. So with the 5 is like um, um, Can we go any further though? Probably. Let's start with start 7. Yeah, it doesn't matter. It's still going to start with 7. 6, same shit. 7, same. But when it include 8, and then things start to get interesting, right? Because after 1 year, I will get all possible combinations, you know, because I will have 0 to 7. So that means after 1, 1, 1, 1, which is like 15. 15 to 15. Now, okay, now this is coming into shape. Yeah. It basically like, okay, if our n, if it is like for example 10, I'll say like, okay, which is what is the a digit, how many digits it does have in binary digits, log 2 base n, and we'll get answer like 3. I'm sorry, 1 plus log 2 is 9, yes. And how can we um for example log 2 is 4, it gives us 2, or 4s, okay, log 2 is 3, it gives us 1. Yeah, 1 plus log 2 is, I'm not sure though. Let's just search in the Google. I think it's fair. I'm not sure if it's fair, but mm, how to get. Yeah, it's like 1 plus log 2 reason. I mean, I knew this. Actually, I just get a bit confused. But anyway, so when I know like there is 3 digit, I'll be like, you know what? The maximum that you can get is 2 minus 1. And the minimum you can get is 7. So, the truth. So like 2 minus 1, basically 2 is the answer. That's it. That is it. So I don't know. It's really wrong. Because I can see many wrong answers. So are people thinking like me and getting wrong answers? Let's find out. Mhm. Because already 4,000 people are accepted. So nums is a permutation of 1 to n. So we'll basically like take the size and we're good. We don't need anything else. 1 plus log 2 is n. That's the number of digit in binary. So the rest of this is basically the power of 2. I don't know. I just say these things. Um, how to say brown? 1, 2 minus is 4. So 1, 2. Oh, 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 oh. What do we have here? Okay. What about 3, 1? Yeah, I think why though? Like for example, if we have 6 which has 3 digit, I'm saying it's 2 cube, which is good. Actually, it's like 3, which is like 2 digit. Yeah, so like what's the problem though? Like for example, 3, 1, 2, there's like 3 digit or 3. So log 2 is 3 is going to be 1, 1 plus 1 plus 2. I think, yeah, but it should be digit. That is very silly mistake. But I don't know. Am I confident on my answer before you submit? Are you confident that this is the right answer? Very good question. Hmm. What else can, for example, let's just double check. For example, we have a permutation of like 7, 5, 6, 1, 4, 3, 7, 2. And first of all, we already know 1 to 7 will be there for sure. And then the thing is, it's, I just forgot. Anyway, so the thing is, 7, it has maximum 3 digit, and we already covered all possible combination of 3 digit. So it can't have anything else. But if we had 8, which is like 1000, then I would say, you know what? We have this 30, and from our previous 1 to 7, they can go up to 000 to 111. So basically, it's going to be like, yeah, up to 50. Yeah, I think we're correct. I think I don't see any error. Okay, so let's just submit. Code. Like it's very weird that it's 3 lines of code, but I think it just should work, man. Please work. Please work. Oh, what the hell? Wait a second. Oh my God. What just happened? Oh, shit. I got wrong answer. Okay, anyway. Yeah. So the thing is, for now, it's 1, 2. Mhm. We know the answer is what? 2, right? Because it has maximum of 2 digit. But okay. It just seems like 1, 2 is special of what, like 1, 2, we don't get 0 here because like you get 1, you get 2, but how can you get 0? You don't, you don't. How can you get 0? You don't. Oh, so you don't get 3. It is a problem because if it is a special case already, okay, so let's just build up. If it is now is 1, 1, how many answer? It's 1 answer. If now is 2, you want 2, how many answer? 2 is 1 and 2. Nothing is absolutely. If it is 3, 1, 2, 3, then I'm like, yeah, 1 and 2 is there. Okay. So it's 3, 3 XOR with 3, if we XOR 1 and 2, we get 0. We get 0, 1, 2. Like for 3, yeah, we get everything. 0, 0, 0, 1, 1, 0, 1. Then we select for 4, we can fill up all those shits and we get 0 to 7, for 5, 6, 7, for 8, we get, after once we get for 3, everything is works out fine, but yeah, it does not cost. So basically, the thing is, if n equals 1, 1, 2, These are exceptional case. And for the other case, because when n equals to 3, we get all 0, 1, 2, 3. And for 4, we get all 0 to 7. So that's why for 8, we'll get from 0 to 15. So rest of the things follows. But wait, what about, for example, no, for example, for 6, mm-hmm, 0 to 7, that's it. Yeah, I know it's right now. It's so annoyed to be honest. But okay, so it's accepted. Oh my God. Oh my God. I can't believe we messed up on test case 1. And if we were a bit careful, we would have, damn shit, man. This is just. So, can I see my ranking? It's pretty bad. I have a, oh boy, this is not fair. This is absolutely not fair. But well, what we can do, let's just confirm. We do have uh 1 hour left. I'm not sure I can solve this problem, but let's try. Yeah. Okay, so what the problem statement says. So first of all is everything reporting properly. Yeah. You're given an integer array nums. Again, XOR triplet. You're here again. Yeah. Now, the only difference with this problem with the previous one is, this is on permutation. The previous problem was so much easy because we had permutations, right? Like we just had permutations, the things are like super simple. But if you remember, I was actually trying to solve this problem for us. So, okay. So now this, in this case, it's not a permutation. So anything can happen. Yeah, anything, anything. But have some idea, right? First of all, we need to figure out the maximum number of digit any number has in binary form. So for example, if we have permutations like this, 5, 7, 15, 12, I will be like, okay, who is the maximum? Let's say, like, for example, not 15. Let's say 12 is the maximum and 9. I will like, okay, 12 is the maximum. That's the max. How many digits it has? 4 digits, right? 8404. I am certain that my number is definitely not going to exceed 50. Definitely. And as like the previous one, the number of unique values will be still be there. Now, first of all, now, okay. Now, what's next, right? Yeah. Now we get the tough part. How far is going to go? Because it's not a permutation anymore. So this is a tough. This is the tough part. Yeah, definitely this is the tough part of all. That okay. So mm, okay. Let's sort them again because that simpler. Now, mm, this question, the constant same will be always the same. Oh no, 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 no. Oh my God, why I'm so bad at studying problem. The constant is definitely not the same. Now, nums is much smaller and the numbers, they're very small. Like 1600 basically means we will have, I don't have calculator. It's log to the 1600. It's like 10. So maximum binary digit they're going to have is 10, you know, which is like very small. Very, very small. Now, now that matters a lot, right? Now, oh my God, why I can't give the problem properly? Oh my God. Anyway, so that basically allows us to just loop double loop, right? 1000 into 1000, 6000 into 1000. Can we do triple loop? Probably not, but double loop we can. Um, mm, yeah, so yeah, if I just directly try to, triple run in triple loop and try to solve the problem, it won't be solved. Like, it will return complexity. So then complexity. Because again, um, in first of all, how many loops is going to have? Um, what, like 1, 2, 3, 4, 5. Usually it is 6 into 5 into 4. What is second? I'm a bit confused. Usually it is like 4 into 3 into 2, 24. But now it's not going to be 24. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 2, 3. And that's it. Wow. Wow, wow, wow. Why though? Usually it is like 5 into 4 into 3. Right, but that's it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just dividing it with 3 factor. Yeah. Okay. So like 1500 into 1500 into like 1500 divided by 6. Um, again, calculator. Oh, it's supposed, but yeah, it's still going to get time limit exceed. Um, we can't like do proofs. But anyway, let's just focus. So 2, 7, 10, 12. We have, okay. For example, we have this 2, 7, 9, 12. As I said, the maximum is 4 digits. The maximum can be 1, 1, 1, 1. So, and like the minimum is, and obviously minimum always can be 0, 0, 0, 0. Like, yeah, from this to this. Um, so can I like do it this way? Like, if 0, 0, 0 is possible, like if I arrange every single number in their binary form, for example, I just arrange them in this. This is the first digit, second digit, third digit, fourth digit. I'm like, okay, I want 0, 0, 0, 0. Can you give me that? So like for the first digit, I want 0. Okay. How can I achieve 0? I can achieve 0 by 1, 1, 0. I can achieve 0 by 0, 0, 1, no, 0, 0. Right? Is there 2, 1? Is there 3, 0? No, there is not. Is there 2, 1 and 1, 0? There is. Yeah, I can achieve this. Can I achieve this again? Yeah, I can achieve this. Can I achieve this? But no, it's not going to work like that way. Actually, it's not that simple because yeah, from you're taking digits from different numbers at different position. It's not going to work like that. Okay. Okay. Mm, I want to do it this way. Like, can I exit seriously? Um, I'm just getting excited. Yeah, so sad. The thing is so bad. Try pushing the phone. Problem can go pretty good accepted, to be honest. Then the number of unique people are high. Okay. I'm not going to try anymore. I'm just going to end the contest. I don't feel like solving it. Oh man, should we try? I mean, I'm not very good at bitwise. I'm actually very bad. Like bitwise, it's a topic that I don't have enough knowledge to be honest. I don't really know the properties of its solved, so it's just hard for me to solve without having enough knowledge. So we have 2, 7, 9, 12, and I want to see how many unique number we can produce. So first of all, 2, 7, 9, 12, they are fine, 4 unique numbers I have. And then like maximum, they can go up to 1, 1, 1, 1. Now, when it was a permutation, things was very simple because we saw now what do we saw? Okay, so this is going somewhere. For example, two, how many tools to have like two, 702. Let's just calculate how many permutations we can have with the first three digit memory. Like you can have like context we have one or and I have the five. It has three. I'll just ignore the one. Ah, this is I don't know. They just reduce the constraint. Still, I'm not being able to solve. It is so frustrating. I'm just going to like brute force, you know? Yeah, why not to do that? And yeah, it's better to just sit down. You know? It has logarithm properties. So this is the brute force solution at least. You know, we can at least solve the problem. Before is ah, I mean, so this is the brute force solution, which takes time of 1500 into 1500 into 1500 by 6. Definitely it's going to get time index it. I'm so bored. Let's just start. Who knows? Who knows? Yeah, for sure. It's going to get time index it. But what if we just, first of all possible double values, which find the exorts of them, so there are like 1500 into, yeah, like, I do that. Like, first of all, like, double values, you know, I will have the XOR values, which not going to exceed, a lot. And then that XOR value, I think it's not a bad idea. Is it going to give the correct answer though? It's, let's do it. I think it's going to give the right answer as well. Double fifty. It's a very bad variable, and to be honest, it's not a double visited, like visited for the double values anyway. You don't have time. Um, also, like if we take from zero to, we are going to have some repeated values, but that should not be a problem, right? That should not be a problem. I'm writing like this. Like the idea is double XOR is not going to be that long, you know? No, it's also XOR is having green. I think it might have some problem. Maybe this we get a double digit value. See, uh, ignoring did happen. Oh, what the hell is this? That's why I do quite solo. Quite a system. You should want. Oh boy, oh boy, this is, I think this should work. Like, I'm not 100% certain this will work. Oh, accepted. Wow. I mean, okay. I mean, the solution, I'm not very satisfied with the solution. It's not a good solution. It's like we just like I just utilize the constraints, because nums are so small, and I always knew that the number is not going to be that large. So, it's the good solution. It's definitely not the best solution, but well, we solved. So, and this is our very first contest. Yeah, this is so good. I mean, okay, so I'm not going to even try the last one. I'm definitely not going to be able to solve that. But yeah, it's very good to see. But still, wow, my ranking is still so bad. I mean, if I wasn't able to solve, I think it's going to be like even worse, right? 6,000, even after this much. Wait, the ranking just changed, huh? Yeah. Okay, so I think this is a very good start of Leetcode contest. We should have 16 minutes, but I'm not going to approach problem 4. I don't even want to read the problem. I'm not very good at graphs, so whatever. I'm happy. Well, it's Genie 2.5 Pro. It's better than all. Huh? Well, whatever. Pro. Oh, processing though. It's also. Anyway, we're happy. We solved the problem. Thank you very much. Although I could not explain the problems that well, I was speaking bullshit, but yeah, that's it.